we just run through this. Today the camera is not going to help our work, but we just manage, right? Today I want to talk about fractions very quickly. We say a fraction is a part of a whole. A fraction is a part of a whole, a part of something. If I say a fraction of the class, I'm talking about a part of what now? Of the class. Is that right? So if I say something like 2 over 6 of the class, I'm saying out of every 6, you take what now? 2 parts of the class. Is that right? I'll come back here. But let me run some here very quickly. Very quickly. Okay. We have different types of fractions. We have common fractions. We have decimal fractions. We have percentages. These are the basic type of fractions that we have. Common fractions, decimal fractions, and percentages. Anytime we have a fraction that we write a numerator over a denominator, we have a common word now, fraction. So 2 over 5 here, and then 7 over 3 here, and 19 over 27 here, they are all what now, common word, fraction, examples of common fractions. Are you with me? Then we have, okay, so I have decimal fractions. If you keep dividing the numerator by the denominator until you get to a final point, you get a point that continues like that, you get decimals. These are decimal fractions. Like something like 0.2, 0.562, 0.333, this one goes on and on. These are decimal what now? Fractions. Before I go on, let me talk a little about what now? Decimal fractions. Some will say I'm running too fast. Just trying to beat the time. So we have different types of decimal fractions. And note that every fraction we can convert common fractions to decimal fractions, like we can convert what now? Common fractions to percentages, and we convert percentages back to decimal fractions and common fractions. Because they are all what now? Different types of fractions. In this case now, okay, I want to talk about decimal fractions. We have terminating decimals, we have recurring decimals, and we have some decimals that are neither terminating nor what now? Recurring. Very important that you know this, especially for numbers. A terminating decimal is one that if you convert from common fraction, it will give you a value that ends. Like 2 over 5 is equal to 0.4, it ends. 4 over 25 is equal to 0.16, it has a final point. 1 over 2 is 0.5, it has a final point. 3 over 4 is 0.75, 11 over 6 is 0.6875, 7 over 8 is equal to 0.875. These are terminating decimals. Then we have recurring decimals. What are recurring decimals? These decimals will just keep going on and on, following a particular pattern. Like 1 over 3 is 0.33333, it goes on. See that decimal point? That point on top there, it goes on and on. The same for 2 over 3, 0.666, it goes on. Then 5 over 9, I have 0.555, it goes on and on. Then 5 over 6, I have 0.8333, it just goes on like that. Then see one very beautiful one, 2 over 7, we give it 0.285, 714, 285, 714, 285, it just goes on and on now. And on. But those are recurring words, decimals. And take note, any fraction that is a terminating decimal or a recurring decimal, we usually refer to those kind of numbers as what now? As rational numbers. Very important. They are rational what now? Numbers. Rational numbers. Any one at all that you have, numbers. Rational numbers are common fractions. They are numbers that can be expressed as a whole number of another whole number. So usually for you to know whether a number is a value is a rational number, it will either be a terminating decimal or what now, or recurring. All terminating decimals and recurring decimals are rational what? Rational numbers. Very important to take note of that. Is that okay? Then we have what now? We have numbers that they are not terminating, neither are they what now? Recurring. Like root 3 now, root 2. Is that 1.41, 42, 13. It doesn't follow any pattern. The same thing with root 3, doesn't follow any pattern. Root 12, no pattern. Root 20, no pattern. 4.47, there's no particular pattern, and they don't end, just go on and on. These guys, this set of numbers here now, excuse me. Let me take this off. Okay. This type of numbers, these sets, we call them, these ones are irrational. irrational number. Before you now say every square rooted number is an irrational number, please take note, not all square rooted numbers are irrational. For example, now we see that the square root of what? The square root of 25 is equal to what? It's equal to 5. So this case now, this guy is not irrational, it's not an irrational number, because it's giving me a whole value. Do you understand? Even in this case here I'm having the square root of what? Of 36 over 49. I will end up getting what? 6 over what now? Over 7. In this case, I'm not having an irrational number. So it's not every square rooted value that gives you irrational number. But most of the square rooted values will give you what now? In fact, just as a simple rule, for it to be irrational, as long as the number is not the perfect square, the square root must be what now? An irrational number. Perfect square are numbers like 1, 4, 9, 16, 25, 36. Because if you find the square root of 1, you get 1. The square root of 4, you get 2. The square root of 9, you get 3. The square root of 16, you get 4 in that order. So these perfect squares, if you get their square roots, they will give you irrational values. They won't give you. So remember the emphasis is actually decimal. This type of decimals, they are neither recurring nor what now, not terminating. These ones, anytime you have this type of decimals, these ones, we see what we have is what now? They are irrational numbers. Because they're neither recurring nor what terminating. Let's rush back quickly to where we came from. Percentages. The 1%. Okay, let me get this. What does the word percent mean? Percent. Power means divide. Cents means what now? Cent refers to 100. So if I write 30%, what I'm saying is what? 30 divided by what? 100. Power is divide 100. 30%, 30 over 100. Is that okay? Percentages are another form of what now? Of fraction. That's my emphasis. Okay, this is an example of percentages, 40 over 100, if I would know that, right? Then sometimes we can want to compare one fraction to another. In comparing fractions, we also have different types of fraction under comparison. So if the fraction, all of them, they have the same value. Okay, let me give an instance quickly. I hope this works. I'm trying to deal with the time. If I have something like this, if I divide it here, this is going to be equal to what now? Please, don't mind me. This is going to be 1 over 2. This same fraction that I've divided 1 over 2, if I decide now that I want to divide it into 4 parts, remember this part, let me get a different color for it. Okay, so I've separated it. If I divide it into 4 parts, 4 equal parts, the same part that was 1 over 2 will now become what? 2 over 4. That is 1, 2, 3, 4. I've taken 2 parts. Before it was 1 over 2. If I decide now to divide it into 8 parts, count it 1, 2, 3, 4, 5, 6, 7, 8. The same parts that was 1 over 2 becomes what? 1, 2, 3, 4. 4 over what? Over 8. I get what I'm saying? Anytime we have this kind of fractions, I will explain better what we explain by equivalent fractions. They are called what now? Equivalent what? Fractions. So equivalent fractions, you're not just thinking about one particular fraction, you're comparing what now? Fractions. And all of them, they have the same lowest term. The same lowest term. If you combine them to decimals, you must get the same what? The same value. Are you with me? You take a calculator and combine them to decimals, you get the same what? The same value. What are like fractions? Like fractions are fractions that have the same what? Denominators. You see them here, 1 over 5, 2 over 5, 3 over 5. All these are what? A set of what? Like fractions. These are another set of like fractions. 2 over 17, 19 over 17, 13 over 17, 8 over 17. Now what are unlike fractions? Like fractions do not have the same what? Denominator. I have 1 over 5, 1 over 6, 1 over 7. These are unlike fractions. 6, 7, and 5, 6, and 7, right? These ones 7, 8, and what? 9, 11. They are unlike what? Fractions. Are you with me? Okay. I think I have to leave here and go back again. Let's talk about common fractions. Common fractions. They are actually called common fractions because they're the commonest of all the fractions. Is that right? Is that okay? Let's break here a little bit.